Welcome to Microsoft Excel with EJD. In this video, I'll be looking at linear and multiple regression with Analysis ToolPak. Of course, you can do regression by using the regression formula and things like that. But the Analysis ToolPak is an add-in in Excel which has made this process very easy for you, taking away all the need to have very complicated formulas, right? Of course, to do multiple regression using Analysis ToolPak, you have to be sure you have the ToolPak in the first place. So, like I think I described this in the video about descriptive statistics. I forgot to do that in the last video on, I think that was, yeah, I think that was still descriptive statistics, right? So I think I was supposed to, okay, I think I did that. Yeah, I forgot to do it for the last video. Was it on Oh, yeah, this is just the second one on regression. Yeah, I think you're good to go. No worries. All right. So, here now, I'm talking about linear and multiple regression, and we have this, I have this data set designed for that purpose. Okay, so we have sales, advertising, spend, and price. But first of all, let's get the background of what regression is about for people who are new to it. Of course, you can check out my statistic playlist in this on this channel, and you find 35 videos on statistics where I dealt with issues relating to regression and all that. So regression analysis is a powerful statistical technique used to understand the relationship between a dependent variable and one or more independent variables. It helps in predicting outcomes, identifying trends, and quantifying the strength of relationships between variables. For instance, I have sales, advertising, spend, and price. So given this all this data now, all this these are my sales, for a particular time, not the timing is not specified, and then this so when I spent $20 or whatever I spent on advertising, I had 100 sales. When I spent 25, I had 120. When I spent 130, I had 130. When I spent 30, then the price is when the price is 15, I sold 15. When the price I sold 100. When the price is 14, I sold 120, like that. So the whole idea of regression is, given this all this data now, how does so I'll be doing a linear regression if I'm only interested in how either advertising spend or only advertising spend, how it influences sales, or how only price influences sales. But it will be multiple regression if I am interested in how both advertising spend and price or any other variable, how they all determine the sales, right? And that is exactly what we are here for. Okay, so we have linear regression, like I said, it explores the relationship between a single independent variable. So our independent variable here obviously is sales. So we want to see, our outcome should be sales. That's the predictor. And a dependent, so linear regression explores the relationship between a single independent variable, the predictor, and a dependent variable by fitting a straight line y equals mx plus c, right? And then for multiple regression now, so for linear regression, it's how advertising spend influences sales, or how price influences sale, or any other one variable, how that one variable influences sale. That's linear regression. But multiple regression extends linear regression by involving two or more independent variables to predict the dependent variable. So why do we need to use the Excel's Analysis ToolPak for regression then? So Excel's Analysis ToolPak is an add-in that provides advanced data analysis capabilities, including regression without needing specialized statistical software. It is widely accessible, user-friendly, and integrates directly with your data in Excel spreadsheets. So now, if you don't have the Analysis ToolPak, how do you know you have the Analysis ToolPak? I talked about that in the video about descriptive statistics, I believe, right? Yeah, most likely. Okay. So, you will know you have this tool if you come to data, for instance, and you see you have data analysis. So if you don't have this data analysis showing here, this data analysis adding here, then you have to come to file, you go to options, and under options you have add-ins, and then you have this tool packet. So you can then you can say click on go, right? This is taking a bit of time. I wonder why. Okay, now it's here. So if I uncheck this now and say okay, so you see it disappears. So you are most likely going to have no data analysis like this. So if you don't have it, before you can do regression or even descriptive statistics, you need to have that. So all you need to do is come to file, come to options, then come to add-ins, click on Analysis ToolPak like this, click on go, and then you can click on Analysis ToolPak again, and then you say okay. And once it's okay, you have data analysis here. So with this now, you can go ahead with regression. So I'm going to do, so first time I'm going to do, in fact, I'm going to do like three different things here. I want to see how advertising relates, how it influences sales. I want to see how price influences sales. Then I will now see how both advertising spend and price influence sales. In that case, I'll be talking about multiple regression. So let's start with two linear regressions. How advertising let's start with how advertising influences sales. So what you just need to do in that case is you come to data analysis, all right? And since you're interested in regression, so you scroll down to regression. So here, where's regression now? Regression. Okay, let me just move like this. Regression. Yeah, I have regression. So once I click on that, my input Y range, that is the outcome I'm expecting. That is the sales now. So I click on sales and scroll all the way down. Oh, I think there's a shortcut for this. I think it should be shift down or control down. So, but I have this now as my Y range. Then, since I'm interested in only how advertising spend influences sales, so I click on input range X and I come to, okay, let me clear this out. Okay. So we come to the beginning again. So then I click on advertising spend and I scroll all the way down, or if you know the range off and you can just type it in there like that. Okay. So with this now, I've only put just one. I've put only this is sales, this is advertising spend. Then what do you want? If you want labels, you can have them. If you want confidence level of 95%, you can have them. If you want your output range, where do you want the output range to be? But I would rather go for a new worksheet. Then if you want to see the residuals, the standardized residuals, the residual plots, the line fit plots, the normal probability plots. If you're interested in all of this, just check them. And once you're done, I mean, the formula for regression is very simple, but if it involves multiple data like this, it can become very tedious. But Excel has made it so easy for you via the analysis toolpak. So by just choosing this, I just click OK, and then it opens a new worksheet simply, and then I have my results easily. Okay, so I have the summary output. So it tells me how good my regression is. The R square is 0.99, which is excellent, almost 100%. Adjusted R is also like that. Standard error is 5.12. We have 93 observations. So then you can also see the regression here. You have the ANOVA table talking about all of this. So so if you need to know how to read all this ANOVA table and everything, check my statistics playlist like that. So the significance, you can see the significance is very small, like very infinitesimal. So what we have is significant. So we can then do the intercept. It is y equals mx plus c. So the intercept, this is c now, and this is the range. This is the slope, right? So it means that for every one extra unit of advertising spend, you have at 1.02 multiple, of sales, right? So basically, the more you spend, the more you get sales. That's what this tells us. And this is intercept. Intercept simply tells us that even with zero advertising spend, you already have 113.229 in sales, right? So that's what that tells us. And then you can then begin to talk about the standard errors and all this, the T statistics, the p-value. The p-value shows it is significant because this is very small. This is 3.8 times 10 raised to minus 95. That's very, very, very small. Then you can have the lower 95%, upper 95%, and all this. All this data can be very useful in whatever reporting you want to do. So in one blow, you can see we've done the regression, and then if you need the residuals, I mean, to do the math behind this, it's a lot of work. So you have the predicted sales, the residuals, the standard residuals, and all of these things. Then you even have you have the percentiles even. So you have the percentile, you have the sales for corresponding to the percentiles. Then you also have the plots. So you see the plots this way. So some of these are you have the normal probability plots. So sales with the sample percentile, we have this. Okay, I can even delete this so we can see the rest. Now you can see the advertising spend. As we can see, right? Sales increases with advertising spend. like this. That's what this is telling us. Advertising spend line fit plots. So what if you want to also see other things now? But this is like the most important one. So you have the predicted sales and you have the actual sales like this. So this simply tells us that the higher the advertising spend, the the higher the sales, basically. Now, having taken care of this first one now, okay, so that is linear regression where we see how advertising spend determines sales. And we see that advertising spend increases, sales increases based on the data. All right. So what if we want to do linear regression and to see how price influences sales? Again, we go for data analysis, all right, and click on regression and we say, okay. So now your data range is changing. Our input range is still sales, right? Nothing that doesn't change. But then our input, our so the range for input now is C, that is price, right? So I also just highlight from the first cell, from the even the title. Okay, this goes as far as A94. Yeah, I can't see it, but I can trace the number here because this is 94, right? So with that, every other thing is in place. So if I run this 90, it's going to open it. The other one will open sheet 2. Now the next one is going to open sheet 3. So I just click OK. So I have sheet 3 now. So again, we have all these data right here, all this information to tell us about how price influences sales. Okay, let's see. Will higher price increase sales? Most unlikely, of course, because the cheaper something is, the more people want to buy. So, and that's why you can see this is the most important part. This is the first place you come to. So even at zero price, you already have 481 sales. But for the higher the price, the lower the so you can see the price has a negative effect on the sales. So that's why the coefficient is minus 31.98. So it means that for every unit of increase in price, you have minus 31, roughly minus 32 less sales in like that. So that is what this tells us. So we can see that advertising spend increases sales while increasing advertising spend increases sales, and increasing price reduces sales. That's what this tells us. And the graph, of course, you can also see, and of course, this one is not as the regression statistics is not as good as what we had before. So this comparing this data, it's not as good as that because the R squared, these values are really weak compared to what we got for advertising spend. Now, what if you don't want to see all the graphs? Okay, let me remove this now, because the most important one is okay, should I just delete now? Delete, sure. Delete. Okay, let me expand to see what this is about. So this is what we are really interested in, or I can just move it away. Good. So you can see this is the real deal now. So you see that as price increases, the sales come down. Okay. So it means that you want to do your pricing in such a way that you don't uh, uh so you don't lose you don't fix your price in such a way that it becomes prohibitive and people don't want to buy. So that's the beauty of regression, right? Now, let's go ahead and see. We have seen that on its own, right? Advertising spend increases sales while price reduces sale. So let's go for multiple regression now, where we see the impact of both advertising spend, and price on sales. What's the cumulative impact on sales? So again, we go for data analysis, okay, regression, and we click can I move this? And we click OK. So with that OK now, so now we are not interested in just price. Now we are interested in both advertising spend and price. And the beautiful thing is it's better if they are joining. So your input range will now be advertising spend and price together. So you see I've extended that. Then I'm now moving it all the way down for both of them together. Now I'm doing multiple regression. So once this is ready, I've clicked every other thing. So it's going to open the results in sheet 4. So I just click OK. Now this thing we have just done, and it looks very easy. It's not that easy in reality, right? So, so let's see. Like I said the other time, um, the most important table you want to see is the equation you get at the end of the day. This coefficients, very important. So at zero advertising spend and at zero price, you already have a sale of 127. That's what this means. But then every increase in advertising spend, right? Every unit of advertising spend increases sales by 0.99, so to speak. And then every increase in price reduces sale by minus 1.8. Now you can, one beautiful thing is here is that the other time we saw that the when it was price alone, it was significant, right? I mean, it was bigger. The coefficient was really big. Where's that now? Okay, it was minus 31. But when you put the two together now, it mitigates the impact. So here, for instance, in sheet two, we saw advertising spend had such a huge, okay, well, not so huge. Last, it had an impact of 1.02. But here in sheet four now, putting the two together actually, gets to help a little bit to minimize the sharp increase in price. And so you see the coefficient is now minus 1.81 instead of minus 31 before. Now this one is advertising spend is a bit moderated to 0.99, which is still very close to 1.02. So you see, putting the two variables together makes you get a better view of what is really happening. So this is normal probability. So let's if we remove, I thought I can delete this. Okay, this is gone now. So this is the price fit line plot. This is the advertising spend line plot, right? I wish I could see a joint plot too. Okay. All right. So, okay. So cumulatively, on the whole, right, you have, of course, you can also see that the statistics are looking very good. They are looking so very good. So we have seen that the combined effect of advertising spend and price, they actually get to moderate themselves like that. So they get to moderate themselves, and so you can have a better outcome when you do multiple regression like that. So now, how do you understand the outputs? So first of all, now, I mean, I'm doing the multiple regression outputs. So this multiple R now is correlation coefficient between observed and predicted values, which is closer to one means stronger correlation. So like I said, this means a very strong correlation. Then you have R square. So R square, proportion of variance in the independent variable explained by the independent variables. So you have higher R squared indicates better model fit, of course, close to one. Then you have the adjusted R square. So adjusted for the number of predictors, useful when comparing models with different numbers of independent variables. So this, look very good. But when we did price alone, it wasn't that good, right? Because of it was all positive but weak. Then when we did advertising spend alone, it was, which is even better, 0.993 compared to 0.9997. Wow, multiple regression is even giving a better result, right? Then the standard error is average distance that the observed values fall from the regression line. So that's 3.16 here. For only price, the standard error is very large for price. Okay, for advertising spend, it's small, but for the combined stuff, so you see, combining the two variables is giving us better results. Then we have the ANOVA table. So if you look at the ANOVA table, so this tells the overall significance of the model, right? How significant is the model overall? That's what ANOVA table tells us. Now, look for the significance value f. This is significance value f. So you can see it's a very small number. That's 1.06 times 10 raised to minus 148. That's 0.000, several zeros. So if it is less than 0.5, this is far, far, far less than 0.05. So the model is significant, statistically significant. So it means that this model, whatever formula we get out of this, is statistically significant. And the way you can write this out is to say that sales is equal to 0.99 multiplied by advertising spend, then minus 1.81 multiplied by price, plus 127. That's what the formula will look like. So this formula tells us we have a very good formula to work with, combining the two together. So here, I think it's where's the ANOVA table? Okay, this is also significant, but it's not as significant as that one, So for price, but for advertising spend, I think advertising spend is even more significant. But the combined one is better than all the individual regressions on their own, right? Then we have the coefficient tables. Of course, that's what I'd explained before for talking about the coefficient tables. like that. So it displays the intercept and coefficient for each independent variable. So each coefficient represents the expected change in the dependent variable of a 1 unit increase. So a 1 unit increase in price changes the sale, by minus 1.81, and same for advertising spend. 1 unit increase in price changes the sale by 0.99, which is a positive outlook. So then you can look at the p-values. So the p-values are also less than 0.05. So it makes them really significant. So look at the p-values to test the null hypothesis that a coefficient equals 0 has no effect. So p less than 0.05 usually indicates significance. So these are all significant now. Then talking about the residuals and diagnostics, you have all of this here. So residuals show the differences between observed and predicted uh, values, helpful for checking model assumptions, and line fit plots visualize actual versus predicted value. So you have the line fit plots, all those plots we saw, you can see how these things are behaving. So what are the use cases for regression, right? So you can use regression. Of course, in this case, now we see a very good case of business, right? So it is good for business forecasting where you predict sales based on advertising and pricing, that just like we have done now. Then it is good for economics where you understand impacts of interest rates and inflation on GDP. It is good in healthcare where you can model patient recovery times based on treatment variables, and in engineering where you can predict product quality based on process parameters. So some tips for effective regression analysis in Excel. Number one, you have to take care of data cleaning, where you remove outliers and handle missing data before analysis. Then you can check multi-collinearity. Highly correlated independent variables can distort results. Then you can interpret with context. Statistical significance does not always mean practical importance. So you need to check the context you are working in to be sure that the statistics matches with reality. Then use residual plots. Of course, we saw residual plots here where we can actually visualize so what we are talking about. So to validate assumptions of homoscedasticity, which is equal variance and linearity, you need to use residual plots. Then you can avoid overfitting. So by using adjusted R squared, which we have obviously, the adjusted R squared and cross validation methods help us to ensure your model generalizes very well. Okay, so limitations of Excel Analysis ToolPak, of course, that's limitations. So it does not provide advanced diagnostics like variance inflation factor. It is limited in handling large data sets efficiently. It assumes linearity and normality, which might not always hold. Then it's more complex. So more complex regression models, e.g., logistic polynomial, require other tools. So this one cannot do logistic or polynomial regression like we could do in Python. When I did the statistics playlist on my channel, I used Python, which can handle all of these things. In conclusion, right, you see that Excel's Analysis ToolPak is an accessible and straightforward tool for conducting linear and multiple regression analysis, just like the case we have seen here, talking about how advertising spend and price affect sales. All right. So it provides essential statistics and diagnostics that enable users to understand relationships between variables, build predictive models, and make data-driven decisions. However, users should be mindful of its limitations and complement Excel with other tools for advanced statistical modeling when necessary. Now, when you're done with this analysis, right, what can now help you is you can, just like I said the other time, you can now begin to use this as a formula, like where you can now say that, that advertising sales, is equal to minus 1.81 times price plus 0.99 times advertising spend plus 127. And then that can become a formula you can use to predict. So if you now want a particular kind of sale, maybe you want a sale of 50. So what kind of and then you have an advertising spend of this. How should you fix your price? So that can now guide you into how you fix your price. I think let me try to even demonstrate that a little bit by talking about that. So now we have seen from the multiple regression, we see that sales is equal to 0.99 multiplied by advertising spend, then plus, now it's minus 1.8. Let me take it to two decimal places to minus 1.82 multiplied by price. And then you have the intercept that is plus 127.08. Okay. So what if I open this and I talk about, and then I explain the math, because this now becomes a model you can use. This multiple regression becomes a model you can then use to Okay, let me delete this and see. Okay, add a new page. Good. Then we are talking about linear and multiple regression with analysis ToolPak. So we have this here now. So from the multiple regression we have got, which we've seen is the best result we can get. Talking about the single one and all that. Okay, let me see. Okay, this can come down, and this is here. Okay. So now we have, so we got that sales is equal to 0.99 multiplied by advertising spend. Advertising spend. Okay. Then price is negative. So we have minus 1.82 multiplied by price. Then plus the intercept, which is 1.27.08. What this simply means is this, that even when advertising spend is set to zero and price is set to zero, you automatically have a sale of 127.08. That's like baseline, right? Apart from that, right? What if so now what this means is that every 1 unit of advertising spend you have increases sales by a factor of 0.99, and every unit of increase in price reduces sales by a factor of minus 1.08, right? Now, this model can then be useful for you if you need to make some scientific information. So maybe you're projecting for a sales of say $1,000 or whatever, and then you have an advertising spend of say you want to spend just $150 on advertising. So by plugging in all of this time, you can get the best price you should fix to get that outcome, right? The best price you should get for that outcome, or better still, maybe you want to determine you don't know you have uh yeah, you want to determine sales with a particular advertising spend and a particular price, then you can get your sales from there. So that's how helpful regression can really be. So so this now becomes a powerful model you can use as far as the data you're working with is substantial, but of course it has limitations, but this becomes a model you can use to make business decisions. So with this, I've come to the end of this video. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel free to let me know. We've been talking about Analysis ToolPak in Excel. It's an add-in that helps us to do analysis like we've done descriptive statistics. Now we're talking about regression. In the next video, I think I'll be talking about using histograms to make some decisions. Okay. So if you have not subscribed to this channel, of course, you're missing a lot already. So go ahead, subscribe, and hit the notification bell so you can always get alerted each time a new video is released. Then, of course, you can become a member of my channel by clicking on join, and you see different levels of membership there with different levels of benefits you stand to gain. All right. So don't forget to like, share, comment so that more people can have access to this video like that. And till I come your way again, keep doing data right.